morning. This is this month's edition of the Chemical of the Month from Hazmat IQ. My name is Joe Gorman, and today we'll be doing a chemical called thionyl chloride. So what we'll need is we'll need you to get your books and your charts to work the process. Remember, why we do this is so you can practice. You need to practice to be able to stay proficient at using this system. Okay, so let's look at our charts. Let's review the system. The system is a 4-step system. Remember, step 1 is size up. We want to know if this chemical is above the line or below the line. Step 2 is verification using the book. Step 3, we dress ourselves in the correct PPE and we equip ourselves with the right meters so that we can go down range, which is step 4, and do it safely. Okay, so we'll start with step number 1, size up. Is it above the line or below the line? So look, you can use chart 1, the periodic chart, the blue or red periodic chart, or you can use chart 2. I'm a fan of using chart 2. It makes it easier for me. So everybody turn to chart number 2 and look for this down the alphabetical list, and the first name of the chemical is thionyl, Thionyl. Is it there? Go down to the T's. No, it is not there. So we go to the above the line size up. So as soon as you say above the line, your whole team should be thinking the same way. I'm predicting that this is a gas that's heavier than air. It has an LEL and a UEL. It has a flash point. There's carbon and hydrogen. It has an ionizing potential, which I don't know yet. I'll find that out in the book. There's carbon and hydrogen, so you can use the FID. The chemical is toxic in parts per million. It polymerizes. It's radioactive. It's an acid. It's got fluorine, and it reacts with water and air. Done. It's the same size up every time you say yes to it. It's above the line. Next, if you look at the bottom, it says continue on chart number 3. Chart number 3 does a great job of whittling away other hazards if you can put it in a family. The way this chart works is you always start up in the upper left corner and you're looking for flammable clues. Remember, that is not first name clue. That is anywhere in the name clue. So we look for thionyl chloride. Do you see it here? No, it's not there. So then we take it over to the middle box, which is my corrosive gas box. And I look for, now this one is first name. I look for thionyl there. And I go down to the T's. Is thionyl there? No. Every time I get a note of the flammable, I get a note of the corrosive, it takes me to a red 1. Well, what's a red 1 mean? Red 1 means maintain all those above the line hazards. We'll verify all those hazards once we get to the book. Here's a mistake that I see people making on this chemical. They think thionyl and they go down here to a red 15 and they see chloride. It's not a red 15. For me to be a red 15 chloride, I must get a yes in the carbon and hydrogen box. I didn't get a yes, so I don't go down there. And then it took me over to a red 1. I now have all hazards, and I'll have to figure out from the book and tweak down based on what the book says. So the next step is looking at thionyl chloride in the book. We started out that it was a gas. Again, this is a system that we do over and over again. So I want you to get used to looking at the same place for solid, liquid, gas is the physical description box. In thionyl chloride, it says, sure, it's yellowish, it's reddish, but the key word I'm looking for is it's a liquid. As soon as I know it's a liquid, it's a 150-foot hot zone. Okay, so I already know, if the cops want to know what the hot zone is, what's my initial isolation distance? 150 feet. Then I want to know, hey, where are these vapors going? Are they going up, which would be good news? Are they going down, hanging where people are? Bad news. So I'll look at the molecular weight in the physical properties box. And molecular weight is 119. Air is 29. The vapors will go down. Next thing, flammability. I want to know the vapors that are going down. I want to know if those vapors are flammable. So there's 3 places I look. I look first, LEL and UEL. So let's look. Na. That tells me this liquid's not flammable. UEL, Na, not flammable. I don't even have to look at the book anymore, because if it says Na for LEL and says Na for UEL, I'll bet you $100 it says Na for flash point. Flash point. Na. Look at the formula up here for carbon and hydrogen. No carbon and hydrogen in the formula. This is not flammable. Good news. Next thing I want to know, does this chemical polymerize? 3 places, remember. Formula for the equal sign. DOT for the 3-digit number ending in P, and incompatibilities and reactivities, I'm looking for the word polymerize. It's neither of those. This chemical does not polymerize. Then I want to know if it's toxic. So I go up to the ideal H and I look for toxicity in the ideal H. ND, not determined. That doesn't mean it's not toxic. I have to go to a secondary toxic box, which is called exposure limit box. And if you look there for the NIOSH REL, it says the ceiling, never to be above that level with no respiratory protection, 1 part per million. So is this toxic? Heck yes, it's toxic. So you must wear respiratory protection. Next thing I want to know if I can measure the vapors using a PID. There's only one place to know if I can use a PID or not on this chemical, and that means I have to go to the ionizing potential. The ionizing potential of this one is a question mark. Well, what in the world does that mean? In our class, question mark means the PID will not work. So PID is not going to do us any good to try to measure. So then I look up in the formula, again, for carbon and hydrogen to see if I have an FID that I could use to measure the vapors in the air. There's no carbon and hydrogen, so I don't have the ability to use an FID. Next question. This is a good one here. Is it toxic? Yeah, well, we did the toxic up here in the recommended exposure limit box, but is it corrosive? So where would I find if it's corrosive there? So there's a couple of places to look. This is not a gas, so I can't look in the DOT box. So the next place I'll look is I'll look down here at incompatibilities and reactivity, and I'll look for any clue that this is corrosive or not. So it says down here, note. Note is code for read it because it's freaking important. And it says reacts with water to form sulfur dioxide, which I never heard of, or hydrogen chloride, which I never heard of. So I got to go back to chart number 3. So I go to chart number 3 and I want to know if sulfur dioxide is a corrosive gas. So I look up in the upper left flammable clue box, I get a no. I go to the corrosive gas box, sulfur is there. Sulfur dioxide is a corrosive gas. Next one, it makes another gas when it reacts with water called hydrogen chloride. I go to the flammable box, is hydrogen there? No. I go to the middle corrosive gas box, is hydrogen chloride there? Yes. So that means that this liquid that's not corrosive based on the DOT number reacts with water and now makes a corrosive gas. So what does that mean? This liquid that mixes with moisture to make a corrosive gas, what's the PPE you want to wear? I'll tell you what I want to wear. There's moisture always where I'm working, so I'm wearing level A on this one. And when I'm wearing level A, I'm putting my pH paper on my mask inside of my suit, my fluorine paper inside my suit, and I'm putting my pH paper on the outside and pH paper on an F paper on the outside. This checks the integrity of the suit during my operation. pH red outside the suit, pH no change in the suit, my suit's working. Okay, so that's thionyl chloride now. So this is kind of a cool one because it starts out as a liquid. If it rains or gets wet or moisture, it reacts to create a corrosive gas. So a question for all of you. How would you know from 100 feet if it was reacting or not? What tool could tell you there was a chemical reaction going on? Right, use the temperature gun. And if I shoot the temperature gun at that liquid and I want to know if it's reacting, what will happen to the liquid? It will raise in temperature. If the temperature is going up, I'm predicting there's a corrosive gas being emitted from that reaction. So remember, this is a liquid that forms a corrosive gas. So if you've ever been told to wear a level B for liquids and level A for gases, this one's that I'd wear level A every day of the week. And remember, downrange, level A, I need to make sure I'm safe from flammability. Good news, this is not flammable. So I'm predicting my LEL read is going to be 0. And then I bring my pH paper. I operate safely downrange with my papers inside and outside. Once the operation is over, I'm going to do decon, make sure I do a good decon on it. Don't let people tell you don't use water to do decon because it says it reacts over here. Use water, use lots of water to overwhelm the reaction. Okay, so that's this month's edition of the Chemical of the Month, thionyl chloride. I'm Joe Gorman. Have a great, safe day. Peace.